All right, this is 5.1 third video. Okay, number 20. If your transformation is going from real number to real number, so your input is real number and output is a real number, the square root of whatever that number they give you, is it linear transformation or not? All right, so first let's look at the example and maybe then you can prove later on. If I put a 9 there, so it should be square root of 9, which is the answer is 3, right? Now if I multiply by 9 by 2, so 2 times 9 is 18, right? I'm just using the first property. So T of C X, that's what I'm doing here, okay? So if I multiply by 2, and then it's going to be 18, and then square root of 18. But now I'm supposed to get what? I'm supposed to get 2 times square transformation of 9, isn't it? That's what I'm supposed to get. But like a look at that. So this is not equal to 2 times square root of 9. So the actual number is square root of 2, pull it out. And then you have square root of 9. So square root of, so that is square root of 2, and that's a T of 9. All right. But now your C is not exactly this. They didn't match. I don't know. Just pause this one and think about this one. Your C is not supposed to be 2 square root of 9 like that, but you got square root of 2 times T of 9. So that's why this is not a linear transformation. All right, check this one. All right, one more time. Let's look at other one. This is very, 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 very important, right? So the transformation is going from Rn to Rm. So nth dimension, this is m dimension. So you have so this is like a matrix vector multiplication. So matrix vector multiplication is a linear transformation. I'm just going to say it now. This is very important. You're going to see a lot. I mean, we saw that one in the example way before that beginning of 5.12. I show you some examples. So whenever the matrix multiplied to a vector, that's a linear transformation. So let me show you here. Let's see, A is let me change the color here. So A is m by n matrix, and X is like X is a vector, n by n1, n by 1. It's a vector, so it's a long vectors. So n rows and 1 column. All right. So if I do the matrix vector multiplication, so let's see, C times X. So that means this is this. Now C is a constant. You can always put it outside. That's the property. And you can write down that. So C times T of X. You can do that. If X and Y are 2 vectors, again, n by 1 vector. If you add together, and then that means it's the same thing as this one. And then that's the same thing as that. All right. So this is a linear transformation. So matrix vector multiplication is a linear transformation. Okay. Just keep in mind that one. Let's do another one. These are like a very short one, so I'm going to do quite a few here. Okay. So again, R2 to R2 it goes, and your definition of transformation is X plus Y and comma Y, right? So now you're going to say what happened to T of 1, 0? Where does it map? So T of 1, 0 is, again, like according to this definition, you add first and second, you add 1 and 0. And then second component is just the X, so 1. So that's a 1. So the image of 1, 0 is 1, 1, right? So again, second part, if you look at the second part, find the vector, if any, map into this one. So this is your output. 3, 1 is your output. And I need to figure out what is X, Y, what's the input vector. So again, input vector is definition is X plus Y, X. So I just go back here. If you look at here, and then again, your output vector is 3, 1. So this should be 3, and this should be 1, right? X should be 1 right there. X plus Y should be 3, right? According to this problem here, right? So that means Y should be 2. So what does this mean? If the transformation 1, 2 vector transform, so the image is going to be 3, 1. it transforms. So again, matrix vector multiplication also, right? So what happened, like when the matrix multiply to a vector, that means it transformed that vector. So it just landed to different place, different vector, right? All right, here let's look at a similar example here. Again, this is R2 to R2, so two input vectors, and then this is like a two component in the output vector too. So if I use 1 2, so 1 2 is input vector. If it use that transformation, what happened? Again, the definition is u comma u1 plus 2u2, u comma 1 and 1 plus this one, right? And that's your output is 1 5, right? So what does this mean? If I apply to 1 2 vector, your output is going to be 1 5. So it's going to transform to that vector, right? Again, I need to figure out x, y, but output is 1 3, so that's right there. And then again, the definition is this, so x should be 1, and then your y should be 3, and that's how you get if it is 1 1, you're going to get output 1 3. Right? I'm going a little fast here. You can just do it first and then check the answer if it fits with my answer or not. Right? So let me do one more. Again, R2 to R3. So its input is 2-dimensional and output is 3-dimensional. Right? Just I don't know. You can read carefully here. Okay, there's a 3 here. So first is if I apply to 1 2. So there's 2. It's a vector. 1 2 is a vector. So your output is going to be 2 1 and 1 plus 2 according to this definition here. So and then that's going to be 2 1 3. So what does that mean? 1 2. If you apply to 1 2, your image is going to be 2 1 and 3. That's your range, right? Like this image, right? Again, what is the xy we needed? So that output is going to be 2 1 3. Am I doing this one? 2 1 3 is right there. I think that's the same thing. So you can check this one. All right. All right. That's your examples. I'm going to continue in the next video.